Hello, Midnight Coders, and welcome to a FAFO video where myself and my buddy Comrade Valera are going to fuck around and find out. As we explore the world of machine learning, he's going to take me outside of my comfort zone where I'm all happy and cozy with my Java world and my Spring Boot. He's going to take me into a magical. Oh my god, there's cats everywhere. He's going to take me to a magical world where things can get rusty real quick. Let me get my big head out of here and little head in here. What are we doing? Oh my god. There we go. We're all set up. Hello, comrade. You are on screen. So
Great
is
stuff. I have
so is our buddy
stream.
Martin.
Yeah, I have stream delay, so it's difficult to see when I'm screaming out. Wonder if I can do it better next time, but whatever. I can, by the way, I can add my device sounds for what I'm hearing all the time. I don't know if it's like annoying or not, or extra flavor. I always sit with this thing on. It makes a beep every time when there is a large transaction. So this is what I'm listening to when I do literally anything.
So if we hear
I
big
don't know.
noise,
We can.
if we hear big noise,
Yeah,
you're making money.
No, not necessarily. You can also hear big noise if you lose money. You just hear big noise when things happen. That's the best
Gross.
idea.
That's gross. That's going to get my heart racing and not knowing if I win or lose. If I'm up money, down money. Oh my god! I just hear a noise and I know that my pocket is burning in one way or the other.
Well, okay. Normally, big noise means good because the expectation is that you're reasonably good at positioning, but that's not always the case. Let me try to move me a bit lower.
Now you see. Now, if I was the one that did this, I'd have a woohoo every time I won something or a cha-ching. And if I lost,
no, of course you do. Of course you do. That helps because
if I'm losing money,
helps
it's either
redistribute the attention.
Shit, or I'm just gonna make a fire noise that I just burnt money.
That's very close to what I have actually. Because it kind of helps to redistribute attention to between multiple projects you're working on. If you have like 7 different things you're researching and that are going separately, you put different amounts of money on there are different amounts of money managed by them, and when something big happens, you get attention towards it. So it kind of self-managing. Well, machine learning, right? Machine learning.
Machine learning, yes. As far as I know, machine learning is me telling ChatGPT to do something for me and me learn the output. So, like, that's
all right.
The only machine learning I know.
Let me try to open Firefox with the Excalibur draw, which may or may not crash fucking everything. We will see. Okay. Drum beat. Well, okay, it might crash at unexpected times. So if I just drop at some point, that's the reason. Actually, wait, we had something for like inside Discord, maybe. To like, was it like Discord whiteboard? Listen.
Is there a Discord whiteboard app?
Maybe I've seen someone on it. I have to make a confession. I have a script which looks for all the people with their current connections. That's opening actual account. That's probably a good idea. Which is showing all the things people are doing at the moment, and I remove from threads everyone who is seen doing Roblox. What else? I think something like Minecraft, maybe something else. I have like a list of games which I just nuke everyone. That's pretty pretty useful. Okay, let's try this thing. Whiteboard. What the fuck is whiteboard? Ooh. Okay. Whiteboard. I'll tell you if it works. Whiteboard. The fuck is this? Find the start conversation. Is this here?
I think I might have started.
Oh, there we go. Okay. Yeah. Let me cancel mine. I will cancel mine and I'll join yours.
Okay. I think I got one going. I don't know.
Oh, let's see. I was like,
Okay, where are we?
okay, let's see. How does
Where are we
that?
at?
I have no clue. Oh, all right. How do I?
How do I see this though?
No, but you see something. Maybe we can do. Oh, we have. Wait, how do you? Ah,
Sick.
there you go. Like this, like that. Maybe. Oh, do you see this?
Oh, there we go. Okay, I see it. Yay!
Oh,
Okay.
hell yeah. Oh yeah. Oh, let's go. All right. All right. Okay. That actually might be much nicer. So Excalibur. I mean, okay. Well, yeah. Well, fuck it. Let's do whiteboard. Fuck Excalibur. So right.
Oh, I
Machinery. So the idea, base idea is you just have computer figure out what base what is reinforcing it. Like you same thing, you have natural selection, you have reinforcement learning. There are like other there are other approaches, but this is all news right now. Everything, like all the useful stuff, is just reinforcement learning. So I have it was on my probably. Let me reinforcement
why
learning
don't
book.
I? Wait, what am I?
Maybe I can somehow edit as a shared resource. I don't know. There's this beautiful, amazing. Oh, what?
I can't see.
Do I have screen? Yeah, there you go.
There you go.
No,
Oh,
I have nothing here. I have
oh,
I
okay.
remove stuff. That's fine.
Okay.
Yeah, I'm sure.
I could hear your keys going, and I could hear the keys going, and I'm like, I hear them cooking,
And
but
then
I see
I'm
nothing.
I'm showing on my screen. It's on my camera, I think.
Oh, I can't see the camera thing. How the heck do I get out of here? Oh, there we go. Okay.
That's a good question. There you go. So
Okay.
this is like the Bible. This is the reinforcement, the godfather of reinforcement learning. It is everything you ever need. Well, okay, not ever for like basic stuff, right? For basic stuff, for simple reinforcement learning on simple problems, like solving a maze, right? Solving a maze you can do with this. When we go to transformers and everything, there are much more complex ideas. And to be clear, I do not fucking understand all of them. There's like some intuition here and there which I was able to get, but it's very complex. But it is all kind of coming from the ideas of line here. So we might maybe for the beginning kind of go over the basics here. There's like 400 pages. So
Yeah, give us the TLDR of this baby.
there's not really. It's very dense. Like seriously, like if you want to learn, if anyone wants to learn reinforcement, which one was it? Was it 6? No, this one. This one. There we go. If anyone wants to learn reinforcement learning, this is it. This is the definitive
Do you
book.
have a do you have a link to that book that I can like pop
I
in
have
our
the
chat?
entire pirated thing. We can put it somewhere and then
The
wait.
entire pirated version.
Yeah, of course. Well, okay, I mean, okay, we can.
Not to play on stereotypes, but leave it to the Russian to have the pirated version.
I have entire. So I'm not only abusing pirated version. I also have. I'm abusing GitHub to store it. So I pirate versions and then I put it all on GitHub. I, it is peaceful. Was it right now? Maybe this. I think. Oh wait, no wait. It is so good that it is in open access actually. Just literally go here. Wow, I didn't even have to pirate it apparently. How do I exit the?
That's
Fuck.
what I had. That's what I had to do too. I couldn't figure it out either. I've got it popped out into a different screen. I've got
Was
3
difficult.
screens.
Leave activity. No, I'm not gonna leave activity. What the fuck?
Double click on it. There's an arrow thing that says back to like back. I wound up
Back.
at at the very top. No wait, no, sorry, where'd it go? Shit, now I'm stuck in it.
Okay. Well, I guess I can just leave activity. Yeah, I'll return it. Fuck, motherfucker, it's asking me if it was good. Can I go back to messages, please? No, I cannot. Cool. Right. I will send you a personal message. If I can exit the screen.
Yeah,
Wow.
how do I? How do
Okay,
I get
new
out of this
plan.
mode?
I've just gotta open. No, I guess we're stuck.
There we go. I left
I
the
guess that's
activity.
it.
I left the activity, and I can see
Yeah, but
you
it's still
again.
going for me. I don't. Fuck, 1 sec. I have. Oh, that's another
I
Discord. What? I have echo.
just hit leave activity. That's what I did. I can jump back into it. Oh wait, no. I jumped back in. I started the whole new one. What did I do? Oh
Fuck it,
no.
fuck it. We just sitting there. It doesn't matter. Discord.com. Open Discord.
Oh, you're back in it again.
Yeah, that's fine. That's fine. So let me mute the other tab. There is sound from somewhere. Okay, Discord here, and then I send. There we go. Fine, and I kill it.
Oh, we got it. Look at that.
Should be good.
Okay. Copy. I can paste that into
Oh my
chat.
god, that was the most difficult thing I've done today.
That was a lot harder than it should have been. Okay.
Okay, wait 1 sec. Test. Fuck. Why do I have users left? To meet this. Say something.
Test. 1 2 1 2.
Good. Okay. Yeah, good. All right. So this is the definitive guide. Back from whatever that was to learning responsive learning. Right. Where's the whiteboard? Whiteboard. Yes. Please go. Okay. Nice. There it is. And then okay, these are levers. These dots here. These different. Why? How do I? Okay. There you go. Okay, so these dots are levers. You have, say, 10 levers, right? This is the one of the fundamental problems behind like reinforcement learning and how do you choose better strategies. So say you have 10 levers and they have some probabilities of giving you money of 0 to 1 and you do not know them. It's just like black boxes. You have 100 tries. This is your limit. Now, how do you go about maximizing the value? So at every step, you can pull on one lever, and that lever will give you or not give you money with some probability. And you do not know the probabilities. You only observe the outcome.
Okay.
What is the strat here?
So now, oh, that's a question for me. Okay, so we like what do we?
Oh shit, that's distractive.
So we got 100 tries to figure out everything in the array. Is that what I'm?
Yeah. No. We don't need to figure out, or I mean, we can try to figure out. So one thing we could do is we can spend all our 100 tries on like clicking every lever 10 times, and then we get as accurate info for each of them as possible. But the problem is, once we're done clicking, we do not have any more tries. So wonderful carnival owner, how do I remove whatever? Let us click it 100 times. We do not have more than 100 times. So we need to find a balance between exploration and exploitation.
Okay.
So if we find one like insane lever, so for example, if we find one lever and from our current experience, so we clicked it so far, say 5 times, and all of these 5 times it gave us 1, meaning like profit, like plus and whatever. It gave us profit. That should be point out. then we probably want to continue clicking it, right? At least until it doesn't give us 0 and we have it less than 1, because we know that the maximum is 1, and so as long as our reasonable knowledge of it is that it is 1, we should continue picking it. So in this case, it is trivial. But how do we do it in general case? And there's what is believed to be optimal way with exact numbers of how you balance this. But just give me ballpark approximate strategy.
I'm not even sure to start out with that. Where the hell I'd even...
We can code the test thing which does this. Why not? You can just click it.
Okay, now I gotta figure out how to leave this.
Definitely weird. So it's gonna be how's it gonna be called?
How do I step out of the... Oh, that... No, that's not how I do it. That...
No, you don't need to. You don't need to leave it. It's fine. We will still be using whiteboard.
I just heard the keyboard. I heard the keyboard going, so I thought we were looking at the stream.
Budget. Yeah, I forgot to switch. One sec. Shortcuts. Wait, that's bottom. Top. There we go. My shortcuts. Oh, I love them. Let me put my. I think I'm at the proper position, right?
Well, yeah, you could scoop more. I think a little more to the right.
To the right. I don't know about that. It kind of cuts me. Okay, like this.
Oh, right, because my screen.
Good?
Yeah, we're good. We're good. I realized that my screen was a little bit. There we go. There we go. Now we're good.
Hell yeah! All right. So, let's. I don't know, right? I think what do we have? How to connect it first? The script, this thing, that thing. Make it collaboration. Just fucking steal the entire thing. Why not? And then I don't need this. I don't need none of that. Command, whatever. Parsers and file. Do we need a command? Do we need the? I probably should be 2 commands.
I'm gonna.
While
you're getting this set up, I'm gonna walk away for a quick second. I had too much coffee and not enough bladder, and I should have done this before we started.
Yeah, that's fine. Okay, so put me full screen maybe. Cached. All right. So in the meantime, we do quick coding in Rust. Oh, who would have seen it coming? Rust merchant sound file. Okay, I'm remaking some of my Rust script. Now you can do it in a single file. So we need a command. The command will give us 2 things. It will give us a start, and it will give us a. And we need start args. Alright, and it will give us pull, and then pull args, and pull args are literally just up, pull args, cannot type, like this, lever N, and it's gonna be U size. Do you wanna mark levers by available? I mean, maybe later. Let's make it in for no other. Lever N, just lever. Okay, now this is going to be clap arc. It's going to be derive of clap arc. That's going to be arc short, long. Why not? Good. Now start arcs. This is start struct start. Arcs, and it goes like this, like that. What do we need? We need probably positional for and levers and Jesus Christ, levers, not levels. I have done too much monkey type. I cannot type lever. Levers on. I should this is monkey type, and it has top we do the series. It has top 200 words which exist, and I can type them perfectly, except and the words which are slightly different from this, it takes me like 3 times to get right. I probably should stop with
Myself, I'm the other
top
way
200.
around. I'm good at free typing, but if I have to follow a script or a dialect, I'm screwed.
No, it's fast to like get to it, but no, the thing is, it shows you top 200 words. It's like 200 most used. So I'm amazing with 200, but like
My
200 to 500 on the
my
other slightly different. This is, oh my god.
my head works faster than my eyes and my hands, so usually if I'm trying to read something and type it out, my eyes are jumping ahead of how I read, and like I don't wind up actually typing it because I kind of like speed read through things and jump words around. And
Yeah, yeah. But no, this is specifically for like typing speed. You can't obviously just read the text and type it at the same speed. It's just not how this works. What was it on? We need n levers and we need time probably. Time tries. Let's make it tries. Naming is the most difficult. As always, make like default. Please tell me I'm doing this right. Default's gonna be 100. N levers is gonna. Is this correct way of doing this? Arc. Oh, this might not be the correct way. Oh shit. Okay, we'll come back to this. Arc. And we need to derive clap arc like this. Okay, we have to here. We do parse.
what is the hashtag for? Is that a comment?
Hashtag. No. This is where all the beauty begins and where probe goes nuts. So basically, you can. Well, you know how templates work in C. Oh wait, you have Java. What's in Java? It doesn't support my. Oh fuck. You have this thing.
Yeah,
You have this thing.
data. I don't use data. I hate data. I add data.
No, but right. But you have it. You have the thing where you do like annotation, and then it does the thing, right? I also recall myself using this in Python. So this is like this, but on fucking steroids. So
Okay.
check this out. You have like clap, derive, arc. No, that's not the. Jesus Christ. Come on, please tell me it's loaded. No, it's no, because this is Rust script, so it tells me to go fuck myself. But like, let's go to anywhere. Probably shouldn't be showing this, but whatever. Let's like sessions. No, crates. This is. It's not finished. That's fine. We have. Where's the thing? Okay, for example, deserialize. Why not? We go. Yeah, there we go. So this is the actual code. It looks at the struct, and then it interprets it the same way as the compiler would. It gets the token tree and kind of structures it semantically. Does a bit of token stream. It's called, and then you can do anything with it. So you have ability to just write code which will look at the token stream, and you have types defined for the token stream. You have like ways in which it can appear. There's a crate which does interface wise, and you can literally do anything. You can generate whatever you imagine from what you have under the macros. So this is the macro, right? Deserialize. It applies to the session. So what it will take inside is this part of the code. This will be processed and will be passed to it as tokens. So inside it can look at the tokens and say, okay, I see the tokens, I wish to do this. Now, this in particular is generic, and this is very optimized. We can look at something more stupid like that one of my crates expands to, which is a bit less profound. It will take a while to load though. Because macros need time to build. That's the only downside. Everything else is perfect language. But if you like to drink coffee, that you could end up doing like 10 times per day. I mean, cups.
Trust me, I drink 10 cups a day at least.
Oh hell yeah! So in the time you drink it, you can wait for compilation. Right. Let's see which one.
That's all compilation is. It's just a coffee break of typing.
Yeah, exactly. No, it's still loading. Fuck me, it's still loading. Okay, let's open the definitions. We can get there later. Definitions are here. We completely moved away from ML at this point. We're just looking at how Rust. This is fine. This is what FAFO is for. Okay, it's still okay. This is not Rust. Just for this was Nix. But Rust is still the best language. Okay, macros here. I have one bad thing about Rust macros is right now they will fix it. So this is like I still developing language, but for proc macros you need to put all of them in the same file called lib.rs. Yeah, this is my lib.rs. To be fair, you can do it like normally per project. This is my like shared utilities for like different stuff, whatever, like random things. I have a few here. Let's look at something simple. Probably I had something. No, I think I had like scream it macro. There you go, scream it. So here's the definition.
Scream it.
And then here you go to here you go to tests. Where the fuck were tests?
Just so you know, your camera keeps cutting off like half of your face.
That's because my camera is here and my monitor is like all the way there. I do it so I never have problems with my neck. But as a downside, if I sit like completely right, it's right. So
okay.
Can't too much. I can try to put it like higher, but I have a very precarious setup here.
I think that's
I think
also
that might be.
Are you using your microphone, the microphone on your camera?
that changes every 2 months depending on how Linux feels. So right now, I think it's using my my headphones. This can change in the new version of the operating system. We don't know. We don't know this thing. So okay.
I just thought that was why I could hear you slamming and murdering your keyboard.
No. That's because normally Discord takes care of muting these sounds. But well, normal Discord crashes. You have desktop, but then it crashes with Excalibur. So there is it doesn't match. I have like how many lines of setup actually? Let's actually up 1 sec. Let's up. Tell it to fix this shit. Fix up. Maybe it will fix, maybe not. Here I have Git. No, I have 42. So this is config.
Damn, that's 32,000 lines of code.
I thought it was less. Yeah, it's 32. Yep. That's that's config. And by the way, if you look at breakdown, Rust takes let's say Rust. So Rust is 30% of it.
Fish.
I just remind you, this is config.
What the fuck is fish?
Well, fish is a shitty language. It's a horrible language. It's like it's unusable. But you can kind of use POSIX within fish if you like need to. Kinda. You can just tell it to fuck off and like don't offer it. But also it has better suggestions. You're on Windows because yeah, you have PWS Sage. It's fine. It's actually like really good. Except for how it does errors. It's not perfect. Like there are some rough edges because not that many people use it. But in premise, it's pretty good because you can just use C#, which is a good language, you know, directly in the shell. Normally, how it's traditionally done, stupid language like Fish or SH or whatnot, we can go to my let me move that to shift up here, move.
Is Fish like a scripting language, or is it something that's like object oriented, or like low level, high level? Like what is it?
Let's see. So this is my fish config. Oh, Bitcoin is moving. Okay. You have a fish in here. Let's open like other fish. All right. Yes, this is like scripting language. It's made to be usable from shell directly. Oh. And so it's kind of trying to optimize for it, but it has some fishisms. So for example, this thing It's fucking retarded. Oh my god, why did I allow this? So normally, normal people do if I was like, is it wait? Is it like that? No, fuck. If you have no, is it? It's minus z. No, minus n. I always fucking forget them. Existing. Boom. This is what like normal people bash write, and this is still a bad language to have like POSIX bash. Which is like standardized pieces of random shit which different shells are using, and Fish said this is a bad standard, let's introduce a new standard. Oh no, we have more standards. So yeah, old story. But you don't have to write scripts in it.
When would you use fish?
Well, in a shell, only in a shell. Or bash, like normally it's bash. Well, yes, and this is my like shell config. This is fish in here. This is fish, right? This is my shell config. Like for example, this thing does. This one starts up like a Ubuntu VM, right? This one asks ChatGPT to translate something from why. Okay, cool. Okay, this is outdated. I have a bunch of stuff. Hopefully, I don't hardcode anything. Yeah, so this one positions something over a specific tmax pane. So like I can press this and it will position it over a given tmax pane. For example, this one, which is in focus, right? So. And also when you do any command in here, so for example, like ls, right? This was processed by fish. And so if I do like ls into g lib, this was processed by fish, and all of these commands are valid fish. And also they you can like if test, for example, I don't know, echo. It's something like less. It's like g lib, and then you take size. No, it's something like size. N lines tail something. This is like something I never use, but there's a way to kind of write a command and say if this, then we do like some block of code, right? And it will execute this. This will not run, but just in theory. I prefer to just write scripts directly. So I was doing this at some point. I completely forgot how to do this because this is not how I do this any longer. Now, if I have some code I'm working on and I need to write a script, right? I just go to TMP. This is from like some other object that can be TypeScript. TypeScript is actually surprisingly good for scripting. It has very nice async primitives, and it doesn't take much to write it. So like I do not like it.
I have a buddy of
but
mine
it's fine.
That was teaching me a little bit of
TypeScript. I don't hate it. Yeah, like I hate to say it, but I do not despise TypeScript. I like it more than I should. My Rust religion is prohibited me from enjoying this. But again, so you go here, you go like cmd.ts, for example, and you write TypeScript or you write Rust script, and in here you have like whatever, like connect here, and then whatever, and it just does std command and you like new cat, right? And you do is this here is arcs. And like you can write Rust to process the command you want, or whatever language you're comfortable with, and you can kind of have or bash, why not, and execute the script instead of writing it in the shell and then coming back to it and changing it inside the prompt. Well, how all the coding workflows normally work. Just for shell commands specifically, people in general seem to do it inline. Which I don't think is the best way. But well. We were on. Were you asking something?
No, go ahead. You're good.
No, I just don't remember where we were. Last thing I recall is we were looking at macros, which are beautiful and scary at the same time. We don't have. This is like one of
the closest thing that we have. The closest thing we have is annotations in Java.
Yeah, well, it's kind. Well, it's kind of close. It's kind of close.
It's like
Um,
the closest thing. We don't have anything like
yeah,
it, but
it's powerful. Yeah, yeah, it's just more powerful and takes much more time to compile. But we don't talk about. We don't talk about.
that that's more time. That's not more compile time. That's more coffee time.
Exactly, fair. And also more time out of the job market, but that's a different question. So this is like a very simple macro which I have. It derives basic stuff like debug, and these are like default ones, which standard library provides. This is mine, and this is just a test one, right? So what it will do for this enum, should I make it larger? It's not. Fuck. No. Is this good size?
Better late than never.
Yeah, sure. No, tell me if it's not perfect, because
No,
I like it small. I like to put everything in the same place. It's like all information at
oh,
me,
dude,
and also like Bitcoin price at the same time.
my my IntelliJ is usually on font size 16, so I then
No, no,
have
no.
this.
I'm 9.5. I went to like partial values.
Jesus, Jesus. Yeah,
Yeah,
you're
decimal.
just
So
you're just a whole other level. Man's got eyes of
I
a god.
whether it is working out and actually making it productive is another question. I like to believe it is. Um, So okay, this is like a very simple macro, like again, simplest one of what I have. You see, like this makes sense, right? You see
Yeah,
enums,
the enum
just
list. Yeah,
enum, right?
yeah. Limit
Yeah,
and archive
yeah.
size.
So this is just enum. Right, we derive the thingy. I don't know if it no, haven't compiled. Okay, so what it does now, it allows it to understand that when I say from string, so it will generate functions for from string, and it will go through it. It will generate the phonetics, like ways to say each one of them, and then match against those ways to say each one of those. And so if it
Okay.
sees a string which matches this case, I like it will well create it. It will know what it needs to create. So here we create order type listing
Hmm.
from string, which was just generated. And order is order type, yes, and we check that order type is indeed stop market.
So what does that at symbol mean on line?
Don't worry about it. Don't worry about it. Don't worry. No. This is
Okay.
snapshots. This is a different. This is a different thingy.
Okay.
Are you familiar with snapshot testing?
No, I don't do snapshot testing.
Oh my
It's
god.
just
Oh my goodness. Okay, I'm gonna take you for a ride. So check this out. This is
all right.
very far from ML, but whatever.
All right, let me buckle in.
Uh,
Take you for a
yeah,
ride, Daddy.
let's be
Let's
careful.
go. Let's go for a Saturday night drive, Daddy.
I'm using it everywhere. Everywhere. This is like the best way to test your code.
See,
So
I've
here
I've
is
heard of test-driven development, but like and like going with test first development, but like I've not heard of
I
this.
test first. Yes, test first. So here's what I think of tests. Very original, must I say. My thoughts match exactly with this. And actually, integration test also. So like these two articles are just absolutely amazing for how to test, how to think about testing. And I of course cannot send it because I'm in a whiteboard. But maybe I can send it as text here. Let's see. No, fuck this. I will open a stream and I will send it as a comment in chat. It will be manufacturing activity.
Nice.
I think I have comments disabled. How do I drop this thing? Probably.
Live
Comments, comments,
chat
comments.
is the live chat that's disabled, or?
No. I disable most components. It cannot show me anything. Suggestion. It cannot show me comments. It can just show me the video and nothing else. That's the default. And I have 2 extensions that do that at once.
Oh, jeez.
Not this one. Where was it?
Might be.
That's not take a while. That's so good. Yeah, probably, yeah. Okay, manager. Who would have known it's so difficult to send messages on Discord?
Oh, what I do with this, I kind of figured my thing out here. If you hover down to the bottom, there's like the little show members button. If you click that and then like click on me, and then you can click on
Oh yeah,
that.
I can send you direct. Good. Okay. I can just send direct. Very good. You need to accept it, yeah. So, this is one. This is how to test, I think. Not uses unit integration. Okay, this is second. Amazing articles. Absolutely love them. Live by them. It's not complete. I have evolved, or I hope evolved. I hope I have evolved my process from that point. So, all right. Here is like part of. Wait, no. Some simple rule. Loops, for example, loops. Why not? And loops. Nice. All right. So the way you think about test-driven is you don't want to drive via like unit tests ever. Test-driven can work well when either you know exactly how the data transformations in the final version of your application will look, or like this part of the application, right? Then you write an integration test, which tests how the data gets impacted. So it does not look at any individual functions. This is what unit tests for, and unit tests should just go with the functions and like be there with the functions. They can be written if function is complex or not. Who cares? Integration tests are the things that keep integrity in check. So if you know exactly how data transformations need to look, then you do integration test. If you have found a bug, a regression, and you are, it's a great idea to reproduce it via an integration test and then solve that integration test, because that's much faster. But for that, for both of this, you need a really good testing framework. So, enter snapshot testing. So this is fucking amazing. Check this out. Normally, when you're writing unit tests, or any tests, you need to hard code exactly what happens. So you have like a bunch of. I don't know if I have some old code to do that.
So, just a quick question: Are your tests separated? Like for Java, I have like a source main, and then I have like a source test, where I would put all of my tests inside of the test section and all the source code inside of the main, and I would kind of separate my unit testing that way, or my integration test that way. Are you just writing tests in the same file? Like I see those.
No. I have a very strict rule about this. So if it's unit test, it's the same file. If it's integration test, it goes outside of the application, so it is unable to reason about parts of application, and it just spins up the relevant part of the application from the outside, and then.
This might be a useful podcast to do with Prof. Is to do an actual podcast on different ways to test your project. I can run.
Yeah, well, I think I have it like figured out at this point. I've been like going back and forth.
No, I just mean like podcasts in general, so that other people
could be useful.
Can, like, get an insight onto how like how you as a Rust developer would test Rust code.
We can go in. We can. Oh my god. So okay, you have started and we had another thing which wasn't good, but whatever. So, check this out. I have snapshot fonts. Oh wait, let me first introduce fonts, and then we can get in there. Let's tbmsu fonts tbo. This is the thing that will let me not forget what we were doing. So snapshot fonts after showcase code style, and then armed bandit macros explain around play key armed. Okay, this is a plan. And now it should be shown in motherfucker. Come on. There we go. Oh, check this out. You see this? You see this?
Tebow. Wait, what am I?
No, I have this thing which so it's here. It's very small.
Oh shit! It's
And I had a way to
behind
make
my
it
thing.
larger.
1 second. It's
Yeah,
behind
yeah.
my thing. Whoops. Oh shit!
There you go.
No. Do you have a list up there, like an actual like a sticky
Yeah,
note?
yes, you can put anything in there. So I not only so here are my active code sessions, which are like doing some work. I can look at now. So right now they're either empty or finished. If they're like active or waiting for a question, you can see it. This is my to-dos. So I have current blocker listed as the top. So right now I'm showcasing code style. Not code style. Wait. Called testing. Code style. And it here. This is the current to do there. Yeah. And I have structured in the blockers. So for example, here I can add TBI. Say within this, I can show like I don't know, Rust strings. Why not? Rust strings, and I say this is nested. If this is nested, then it nested, and if I open it, it's going to be like this. So you see, there's like comma here, yeah, and it gets inside. And you can also go like TBP. This is Teddy blocker pop shortcut. So you know, and it removes it, and now I'll be back to this one. And there's also like tracking, so I can put it on Clockify. It automatically I have like all the integrations, everything. But this is like a whole podcast also. Okay, back to what we were doing.
Okay,
we were doing
that just
snapshot testing.
A little bit.
Yeah, I've spent like a bunch of time going around different ways of doing this. So far, it seems to be like really nice because it forces me into a single blocker. At least in the current project, I also have like a thing to switch between projects. I have move to the name of a project here, so I can choose between ones which are selected in like daily for the day. But that's beyond it. So if we have tests, simple tests. So for example, here, right? These are simple assertions, like direct, simple dumb assertions. If behavior changes, for example, this is actually a good example of what not to do. This is a great example of what not to do. Oh, hell yeah. Okay. So this is a bad test. Why?
Okay, so if I'm reading that right, you're
One sec, I'll go to the toilet. Also, I've drank. I also like coffee. So you figure out why this is like a bad assertion. I will not turn it off.
So we are asserting that we're not equal. I'm assuming that assert underscore EQ is equal, and that bang means not. I'm not really familiar with Rust. But we're taking the result, we're unwrapping the error, we're making it into a string, and we're comparing it to in-ear from inner? In-ear? In-ear? I mean, I can see a couple of ways that would be a bad test. No case sensitivity. Not that that really matters. We're not really lowercase in anything. I don't really know, again, what that assert EQ means. but I assume that we're asserting that the error. Okay, so is that exclamation mark supposed to mean that it's not null, kind of like Kotlin? Or is that meaning that it must be that it's not true, like Java? No, because it would be inside the parenthesis if that. Okay, so we're asserting the equality.
Good stuff. Rust questions. Let me answer. Put me on top. There we go. Let me answer the ones which I heard. This is just macro. It means that it will depend. But this is like a simple macro, so it will just do this. How you think of it? We have the same for like println, right? Hello. This is valid. Yeah, this is just macro. So this is a short equality. This is just a way, like a better way to do something. Something. There's like some small optimizations to do there, like a nicer message. So this is kind of preferred over something. Right? So you assert that this equals to the second part.
Okay, so I assume. Okay, I did guess that right. That EQ is the left equals the right. Okay.
Yeah.
Okay.
So why is it the best?
I first thing I look at thinking that there's not really any kind of matching there. If we're trying to compare left to right, I'm not seeing anywhere where we're conforming it to be either uppercase or lowercase. So I'm assuming some case sensitivity can screw with that.
Actually, I don't remember what this particular part. I don't think. No. This is a valid. No, actually, no. It's a valid test in terms of it tests what it's supposed to. I don't remember what it's supposed to test, but I do know that it doesn't fail. So no, it's a working test.
Yeah.
Which not necessarily proves that it's working, obviously, but I'm pretty sure it's a working test. So the problem with this is if I change the behavior to have a different format. So this toString is implemented by a display on. This is small for me. Too large for me. Let me make it a tiny bit smaller. I think this is the there you go. So this is the way it wraps it. See? So if I change this, right? If I change this to something, or if I change what the reason is, this test will need to be rewritten. Which, if it's one test, it's fine. But if you have a shitload of tests, yes, you just don't end up making changes, or you end up like suffering for them when you go like really slowly, and you hate your life. So what you do instead is you go bye this, and you go hello snapshot. So I think it was snapshot like this, and then you do the same thing with VL up. This like that, like this up, and now we run it. Which file is this? Proper cr test proper fuck ct test proper. Now it will fail. It will say that it mismatches. Now I go here and I accept the new result, right? So currently it is this. It wants to have it be this. It did not want to have it be this. What the fuck? Wait a sec. Where are the utils? This is macros. Proper inner. Does it get touched? Snapshot. I think I need to like this probably. Yeah, that was not correct. Syntaxes. Come on, please tell me it's the correct one. Is it? Yes. This is correct. So okay, you see, it failed, right? And it's telling me this is a difference between the old snapshot and the new snapshot. And now if I go, if I accept it, I can say, do I want to accept this difference? Yes. And then check this out. I go here, and I have inline in my code. I know exactly what it does. And if it ever changes, it will show me the difference. And I will just go there and I will accept it if I like it, or see that the problem of how tests work, right?
That's interesting. I like that. It would definitely
this changes everything. And you definitely have it in Java too. This is just such a useful concept.
I was just gonna ask. I wonder if that concept is in Java, and I'd have to toy around with it to
Absolutely,
explore.
there's libraries everywhere, everywhere.
Because like
There's
I'm pretty used
great.
to the like generic JUnit testing, but I've not really strived too far from just typical tests.
This changes everything, everything, because you now can actually do test-driven development. Think of what you do when you want to test some feature. If it's not like large, if it's not a part of some like graphical interface where you need to see it right or like, UI, but say like some logic for calculating a hash or not like some algorithm doing something with data you're aware of, anything like unit testable normally. When you want to figure out if it works or not, you would likely have a few runs yourself with different inputs and see what the application does, right?
Mm-hmm.
What if you make tests with these inputs and then you get back the same thing of what they do, but now you do not lose them. You have the pre-selected list of things you want to run with, and you see the results in line inside the code.
Mm. That's pretty exciting. That's pretty interesting.
Yeah. Yeah.
I'm gonna have to
So I
I'm
have
gonna
some
have a toy
things.
with that.
Yeah. For example, here's like some things I did with this. This is a bit of a like also well everything I do is a crime, so it's fine. This is I think to force my code conventions onto anyone who downloads who uses this, which I just realized it wasn't intentional, but this is even better. So anyone who uses this to set up Nick's files also gets my code style. Code style forces my like best practices for Rust code, and it like ruthlessly overrides everything which is not that. Here's one of the things. This is a tamer one. It's just warrants. So this is like a simpler showcase for snapshot testing. I will have an even crazier one later. So I think the code itself is like pretty simple. We just go also over tokens. We check for like loops, and this is you see we're creating operations, right? So also like tokens, we parse the code. There's another thing that does it, very similar to macros actually. And like we check if we are where we should be, and then that's it. We just go over everywhere and collect loop issues. This is kind of bad code, but whatever. This is logic. And now here are the tests. They are in a different folder because they're integration tests. So they do not see functions at all. They only know that the application has run, and it makes a new file with this content inside a temporary dir which was assigned to it. And we look what changed, or what response we got.
Sorry.
So in
Oh,
here,
just the same to begin with.
yeah,
Sorry,
in
what
here
did I
we
click?
generate a new file. Yeah, in here we generate a new file from this. This will generate a file. This will generate a file and place it in a new directory, and then it will
Okay.
just check that okay, this is correct. So in here, this is like also a source. This is a source snapshot. We will generate a byte file, so a loop, and it doesn't explain why it must be a loop. You know, because I don't like when are in the code. Oftentimes you can get rid of an unterminated loop, or at least you must justify why that loop must be there. But it's just like NASA standards. It's like really easy to just add a loop for no fucking reason. And I just today actually this thing actually like check this out. This thing just caught this just today. So I had some fallback for like config loading at some point. I had a very stupid service setup with this, and because of the byte pattern here, it just caught a byte pattern. I was able to look at it, and since I since then rewrote a bunch of stuff to like be better, I also was able to get rid of it. So it's a useful, check for are we sure this is correct? And there's a bunch of things like this. So if user thinks it is correct, I must explain. I make a comment, I explain loop, here's why this is loop. Otherwise, like rewrite it, please. There you go. So it says this. And this is like a source snapshot which shows current message, currently what's happening. And the best part is this is exactly what the application does right now, and you never need to change it manually. So if I change a message, this is one click to change. Even further, let's go to something that actually rewrites. So for example, I think this one should be able to change chron to GIF. No, it's not able. Hash. Oh yeah, this one. Okay. So this code has some logic for rewriting a slower hash map from standard library in Rust to a faster hash map. From a standard library, it's like secure, but I realized that I myself never actually care for it. So in most projects, it makes sense to ensure that it's not accidentally a hash map, like someone's contributing, I'm being dumb, code data, right? I just overwrite it to a faster version. And in the project where it matters, I just disable this rule. So I don't think I need to show the code. I mean, it's not that difficult. It's not nothing specifically interesting. We just search for this, and we also know like in which context we are, and then we add the dependency like at the top of the file, at the top of module, at the top of crate, cargo, whatever. More interesting for our discussion is the tests. So I have in the associated file, I have tests just for warning. So it just checks that like correct, cool. I have like a sort mode, whatever. This is correct. Born. Yeah, this is a sort mode. And so this is a shortcut to take the provided file. This will be generated, as I said before, as a file on actual temp directory, and the whole program will be run. And it's like it's run on multiple things at once, so it's actually very fast.
I think we're a little far off our machine learning.
Yeah, well, we'll get there. We'll get there. Kind of, it's somewhat connected. You can say you learned yourself to be a better coder. That's fine. So this is like in a short mode. It will just show you a bunch of warnings, and we show exactly which warnings are standing. And that this is format mode. So format mode. This looks at the state of the file after the application was run, and then it serializes it back into a string, and then we can compare it with the previous state. And so if there's an error, if it starts to format to something random, something stupid, I will see it as a difference on this particular test in the format. So I will know exactly what broke where, and if I update the functions to say not a hash set or something like something else hash set, right? I will update it. I will click one button. I will like look once or click a few times to see that the differences match my expectation. And if I like it, I just accept all. That's it. This makes you go so much faster. Oh my goodness.
Huh. That's really interesting. I never really would have. Again, I'm only used to doing like unit tests, which is pretty much rewriting the fucking wheel every time.
Yeah, that changed a lot for me when I discovered it. Also, Matclad articles are just life-changing. There's so many things I learned from there. All right, back to machine learning, maybe. What did we have there? We had, okay, I showed this. No, not machine learning. I have another thing. We do snapshot plots. So, all right.
Let's go.
Check this out.
I'm stretching. I'm ready for this. I'm getting ready. Oh my god, I can't stretch like that.
Normally, when you have any functions which are simple, let me like drawing. Wait, no, snap, no, font, plot. No, simplified. So there you go. All right. This is like some bullshit with like internal testing. I'm not actually using it outside of the crate. So this is how I drew data before. Because like with snapshot testing, it pays a lot to be able to define data as text to then be able to like show it and compare it, so you can compare graphs. For example, something needs to do this, and you can see like what it's doing, right? So I think this is using the stupid way. So this is only using 8 different chars for the height, or like 9, I think. 9, yeah. Like space is also char. This is it. This is all you can do to express the data. So obviously that sucks. I don't like it. So what if we go and we split it to 65,000, and then everyone is 255 different sub how they call it, sub levels inside of it. Every chart there's like 255 sizes, and then I do 2 in the same chart. So I do 2 bars in the same chart. This is old way, this is new way, and it doesn't even get precision because like if you like look really closely inside the pixels, right, you can see like tiny differences in here. And this is just would have been completely swallowed by the old way. And like when testing something more complex, this is really nice. I can show the itself, but that would take too much time. I can show it next time. And then the next thing is actually apparently you can also do candles.
Oh gee.
This is text.
Is this what you
and
were
I have determined.
Is this what you were showing me before when you said you were dividing tragedies against UI designers?
No, that was a different thing. This is I do that daily. Don't worry. That happens a lot. I don't think I showed you this. No, this is pinnacle of snapshot testing. So I have ways to transform arbitrary price series into candles, and then to just draw them like this. And that means that I can do tests on my algorithms which work on candles, and for example provide some output underneath to like show our reaction to it. And this is all in line as text.
I love the upside down cross in the dead center of that.
Yeah. This one, yeah.
No, to the left. To the left, right in the center.
Oh yeah.
No, to the right. That was not it. In the middle. In the middle, kind of where it dips down to the left.
Oh yeah.
No, it's a plus.
People
can see it. People can see it on my mouse. It's to the left.
Oh, okay, that's good enough.
Whatever.
It was actually like very more difficult than I expected to make this like really coherent. And as a nice consequence, whenever I look at my files now, if I'm looking like advanced fonts, I now see candles instead of Rust logo because I overwrote like 100.
That's interesting. I like that.
This was not intended. So, all right. I've shown this. We can pop that. We can go to the next thing.
While we're on the topic of fonts here, did you see the? There's a GitHub out there. I don't have a link to it. I seen it on the Primogens stream, but there was a guy that turned the URL bar into Snake. The game, like the Snake game. Yeah, play a game in your URL bar. Yeah, and you can use your arrow keys to go like up, down, left, right.
Okay, yeah. Oh yeah. That's pretty nice. Okay, yeah.
Like
that's pretty fun. There's also like hosted here now. I think now be now host. No. Fuck. There was something. Hosted nowhere, yeah, this thing. And it like it hosts your just inside URL. Also pretty fun. Yeah, but like snapshot testing is fucking changes everything. Oh my god. So Rust macros.
Definitely gonna have to explore that because I do like right now again. I don't know about like unit test and integration testing with JUnit.
But you can find for Java. Java
Yeah, I left a note to myself to explore that.
Oh, there you go. You have a leap here. So is there? Well, okay, it has debug files, which I like less, but it also works.
We'll explore it and do it in another FAFO video.
Mm-hmm.
We'll
All
explore
right, back to the thing.
we'll explore different ways to test our code.
Yeah. All right, so sounds cool. All right, I think we want to touch macro. Let me kill this. I also killed. Fuck. Okay. Let me just. Come on. There we go. So yeah, let's look at how it was defined. The screaming. I think it was this one, right? No. It's this one. Yeah. Scream drop error maybe. No. Script. This one. Okay. So this is the macro itself. Let's find the address. All right. So basically, you just get like token string. Kill this one sec. You get token string, and print it out right now, but showing normal ST tree, which is like nested everything. You know how they look. And you just this is normal code, and then you have quotes in here, which can use macros. So this will generate. Everything else, literally just trust.
So what is quote? What does that do?
Quote, right. So this is provided by the lib itself. This is like a normal macro. Macro means it will like generate code itself, right? And this is provided by the lib, which is in the RX working with drive macros. And you shove something inside there, and you can use normal like expressions as you would in macros. For example, variant name. It will generate. So this quote, it will generate the following code. It will generate self. Variant name will be taken from whatever it is at the moment.
Okay.
And so this in here, say currently when it's running, right now, say equals to I don't know, foo. You have stream name. Right. So what it will generate here, it will generate well, like this, like that, and fuck. Why? What? That's very weird. All right, self. It will generate self foo, and scream name is gonna be foo. Like this. I think yeah. There we go. That's it.
Okay. Now does that just like print to the console, or like what exactly is that right?
No. This is actual code generated. So
Oh,
this
okay.
is a line of code which will get written.
Okay.
And you can compose.
Okay, I see.
This is a well, not necessarily. No, that connects to our concept of mesh here. Let's look at the next one. This is just impl display itself, and it will use arms here, which is storing the quotes from here.
Okay.
All right, so we generate these lines. It will store it in arms, and then we can expand those arms inside this block.
Oh shit.
So this is like a standard import something for something. So I have like a let me open this. So I have like a struct full bar bus.
So this is essentially generating something and then implementing it, or is it extending it?
So this is like how you import something for in Rust, right? Results.
Public function self.
For example. This is it. Right. So here we generate an impl with like display. This is a trait to generate toString, which we're using here. It will generate both from string and toString. This is standard, one of the standard traits. And what it does, it just generates implementation trait for this struct. If it compiled, it has to go. But okay, what we would see in there, we would see impl order, impl. This we will see. Let me sum down. Oh, up here. Like fuck this. This. What we would see is this code for order type and gets right, and for every arm, it will know like to generate this line. So this line will be like limit. Then for limit, it knows to now write. Stream name is going to be what? It's going to be like limit. Cool. And then also it does it for every stream name which we generate. Also, no, I think it's just stream it. Yeah, I think it's just this. Okay, so it will know to write that for this, and like the next one, for example, is going to be like stop market, right? Right, and it will know to write.
Okay.
Fuck. Market. There we go. And so. So this is what gets generated by this.
Okay.
And the best part is most of it is just Rust code. Most of it is just literal Rust code with nothing that can go wrong.
With nothing that can go wrong.
Well, because it's Rust, it's safe.
I just love
things
it.
can go wrong in macros very fast.
I just love it. Nothing can go wrong. That seems like famous last words. Hold my beer.
Yeah. Well. Okay. So if macro, right, it's much more likely to be inside a quote than outside of it. And with Rust, it saves you from yourself all the times. It kind of forces you to write better code than you would have otherwise, at least. Right, that's macros.
I hear that a lot about it. That languages like that do like Rust force you to. Yeah.
No, but like Rust forces you the correct way. It's good for you. It will make you a better man. Alright, we wanted to do Carm Bandit, right? I was in the process of writing like a for you to play against it. I think let's. Do you want to write that or do you want to try it? Yeah, fuck, let's write it. Well, hopefully I'll be able to do it fast. Okay, so let's see what we have. We have commands. This is collab. Collab is a beautiful thing to also generate. So you see, like this drives, right? This derives arguments. So now this becomes.
I was told getting the clap is a bad thing.
No, clap is good. Clap is amazing. And actually, if you like prime clap.
Oh god.
I think this guy is also no clap is no. Is this? Do you have?
Clap?
What are the time? This? I don't know. He's really excited about this. I think even more than me.
Is that pirate code on there
this
too?
Is.
I
do not know.
With
Wait.
I do not know. Pirate software with them?
Yeah. I don't know exact screen. I just know he really likes clap. He like.
Oh my god. Why am I not hearing your audio?
I don't know. Desktop audio. Wait. Filters. I do not know. Wait, like this? Just test. You hear it? No? No?
No, I hear nothing.
This is not the right clip anyways, but
Anyway.
whatever. Like he's really excited about clap. I was wait, you don't.
I was just making a joke because like around I guess I don't know if it's like that in Russia, but there's a thing around here that clap is kind of a sexual disease.
Oh yeah. Well, in Rust you like getting clap.
Yeah. Well, we got
it's safe. Like Rust is safe. You see, so it's fine.
We have Noob in the comments section saying clap 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 clap. So Noob's in the,
that's the correct sentiment to have.
Noob is in the audience clapping his hands right now.
Yeah, I'm also excited about clap. This is a very good library. I have all my new project generated just by default on, because why not? Let's see. Now we have all right. Let's have CLI. This is gonna be CLI now. It's gonna be CLI. This is gonna be a parser, and subcommand is gonna be actually at the top, like this, and we don't have anything here. We might explain what we do, but actually I'm not going to. So this is number of this tries. This is positional. This is a flag. Okay, this is args. CLI parse this. Let result equals match. Come on, CLI. Come on, CLI. This and it can be. I might enable compiled actually. Or maybe not. Okay. Result comment start. Then we go into fuck one of this, and I go like that, and like this, and then pool. It will have their own. Okay. Just test that it works, I guess. In the start, the slash. What do we have? Weird. Fuck. What do you mean?
Can't get weird.
No, I have. Why does it not recognize it?
I want to get weird.
Is it because it doesn't? Because I don't have chmod on it. Yeah, I have a scripter which does which asks questions to the terminal. You sometimes need it. And then it goes with like I did denial. Yeah, that's yeah. This is it's beautiful. It's this thing. It's basically just this. I do not know why, but why not? That's his BF lost all the money, and then this was his response. There was like explanation somewhere below, but. So all right, we have weird, we have current basic, which now needs start, and then what do we need? 100, and I call 10. It will take a little bit of time to count your terms. All right, it's telling us what's up. As it's drawing very good. Oh, we need debug on this. Right, that's great. Bug. Yep, that makes sense.
Can't get a weird armed bandit.
Clap. Is it sub? No, it's comment, I think. Clap comment, and it's debug. Is that better? Comment, what else? Clone. Why do we need clone? We don't need clone. Calm down. No, we don't need clone. Nuts. Is that gonna? process command. Because it thinks it's. Fuck. Okay. That's not correct. This is clap command. Different command. Other places. Okay, that's good. Yeah, that's fine. All right. What else? Can I paint it? Do I not want to write? Should be good. Should be good. Should be good. Features derived forever. Yeah, like this. Okay, let's see. Here's the bug. I select command. Of course. Click the diameter. Because we need to drive it. Like that. Debug arcs. What do we have? Arcs. Fuck, we need to debug this. And then we need to debug that. There we go. Alright. That looks more happy. Except for this. Subcommand. Yeah, because we need command and subcommand wants to have a clap. Clap something. I don't remember. I don't want to look at docs. So what we will do. This is like approximately how the code needs to look. So now we can do fix. And now we wait for. No. Check out the time. Like check this out. We do like timer. Okay. It starts now. Okay. No, it fucking starts. Why is my timer broken? God damn it. There we go. There we go. Okay. It takes a while because it's Rust. It's thinking about how to do it the best possible way. Definitely the problem with my setup, and then it will just do the thing and look at the docs because I mean I can go to the docs and I can find that this is clap and it has like whatever it needs to have like on commands like because there's some way to like derive command properly. But command new. It needs to derive. It's not correct though. There we go. It's already. Yeah, because it's subcommand. It's me. There we go. This you see because you have like this structure which you define yourself, and then for stupid bugs like this, which would have taken 10 before, you can just make this thing at the correct stuff. So what did I miss? I missed arcs instead of arc. Right? Subcommand instead of command. What else? Default value T, apparently. And yeah, well, okay, fuck off. This is just being fancy. But like the structures there, like, and before it would have taken 10-15 minutes to go, you know, between docs, between like old projects, see how it's done. I didn't do this. It took us like less than a minute. I haven't stopped the timer. Amazing. This is me probably. Wait, fuck. Wait, what? Oh, wait a second. Is it trying like old version? Club. Is my connector wrong? Maybe again. Maybe it's like cached. It might be cached. Cargo. What was the fucking? It was like cargo Rust. No. Z script. Yeah. Cargo minus Z script minus Q. Actually, cargo. Because we have Rust up nightly. Fuck. No, it's gonna be like nightly. Cargo run this. Maybe not. We were missing column. Very good. A single problem with this is that when you start to use nice, there you go. When you start to use it starts to be like it's slightly bit more difficult to about code. But the way I'm kind of working against it is compartmentalizing, right? So if it's like a larger project, I will myself like just not even allow it to touch it, define all the API connectors to a high level, and then I can give a module to it. Or for example, like we looked at the code style before, I'm not going to reopen it, but we had like a bunch of separate rules, right? And because of how the infrastructure is designed to be separate, and so I can let it do whatever crazy shit it's doing inside compartments, as long as it's not spreading across the code base, right? and it doesn't have ability to introduce random methods and like shortcuts around which multiply across the code base, but only do its bullshit inside individual files, and so it doesn't escape. Yeah.
Okay.
All right. This is args. We have args here, which is, well, this is how collab works. I don't really fucking understand why you want to, because it's different argument, of course. Okay, this is different arg. So it was called n, and then tries apparently, yeah, this is to do. So let's do that. Start first one, and levers is 100, and then tries like levers 10, tries 100. Why not? I should probably make this one positional and make this one be bioflag. There we go. And then number 10, try 100. I don't have renaming this, so we'll leave it as it is. Fine. All right. Should be good. Should be good. Because it's like Rust script. It's a new thing. It came out like a year ago. So what do we need? We need to make like a new don't to write it. Yeah, probably just needs to be connect. Connect okay, so this starts. Which one? Choose port. Choose port 65379. 9 and then okay. Args dot lever, boom. Probably need to start effects to range. So do runs do check payoff left. This we need to probably game state. Struct game states. It will have like levers n private and levers, which will have should be like a vec. Probably should be a vec, right? Make it lever values. Ooh, and this is gonna be should be t. No, because we're gonna precompile it. We could precompile it. Vec of usize. Why not? No, it's not usize. It's gonna be float. Actually, it's gonna be percent. It's gonna be fancy, and we can get. It's gonna take forever to compile whatever. Let's not be fancy. It's gonna be float f4, and then what else we need? Do we need nothing? We need impl game state fn build, which will self with now I can write all of this myself, but I do not want to. So write all of the functionality marked with do up. Now
Oh my
we just
God.
wait. That's
now
because
now
it's
a
true.
copy
Like, I don't
break.
want to do this, right? I don't want to do this because it's really difficult for you to mess it up. We do like the trivial. The structure is in, right? It's really difficult to mess up with the implementation details for it. And honestly, like here I want like just to explain what I'm kind of doing. Right now, with current level of AI, you can at this level of the project let it loose even easier. For this particular project, normally I would have made even instructions. You can do this faster. Public is moving. Ooh. Can we? Oh, nice. Right. For larger projects, yeah, there you start, being more difficult. But for small ones, oh my god, it's so fast, so easy. All right, let's see how it will figure it out. It'll figure it out.
Mm.
Things, but normally, like, that's all the code here makes sense.
I feel like I need more coffee. I think I drank it all. I should have put on a bigger pot. I only have the one size pot. I should have put on a second pot.
Yeah.
I've already burned through a pot of coffee through it in this hour and a half that we've been chatting.
Well, okay, maybe we will get over like well, but yeah, the next like 40 minutes. I don't know. So does the code make sense? Like more or less, I can open SSH for you. So you can out.
Looking through it, it's making sense now that I mean, if
Yeah.
you asked me this before we met, I would have said it looks like gibberish to me. But now that I've been kind of going through here, and it makes sense. It makes
It was
sense.
just other stuff. Yeah.
I could read
All
it. It
right.
makes
So,
sense to me, but I couldn't write it.
well, okay. It's very explicit. So if you like really write it for 100%, it will take you longer than in other language. It will break less, and then future adjustments will be faster. But if you write it yourself from like zero up, it will take you more. For example, this is like buff rate, right?
Mm,
You have to everything that can go differently, you need to acknowledge. So if something can drop an error, you reason about it, right? If something can fail, you also say why you expect it not to fail, and will check this, or
mm,
you write the handling, and then all the data types are very precise. There's like the command, if you look at what command from std returns. If you run a command, let's see, you need to do it's gonna be something with processing output. I'm not seeing it here. ITF spawn. Oh, this is tame. This is quite tame here. That's fine. Strings. Maybe, for example, right, slightly more involved, but still not really. Let me find string. There we go. So, for example, if you have a string, something that could be a string, but not necessarily, you just have an bytes. You need to deal with the fact that it's not necessarily a string. It could be some loss here. And wait, no, this is also simple way. I had something that does the fallback for it. Fun. Fuck. Bring. No, that's the default one. Dance, maybe. I think here we ran a command. Right here we ran, for example, here, right? So we run a command, we get output, and we need to ensure that we are checking the success status, otherwise it will not return. Way to get it unwrapped. But this is also not like the most involved, but it's pretty simple actually. Okay, but it's taking some shortcuts. All right. Any operation which is anyhow involved, I guess TCP stream is somewhat. You need to reason about all the edge cases. and like you're forced to by the interface. So if you understand this problem space, you will write it like at the same time, I guess, because I mean, you still when you write normal code, you head inside your head, right? But here, you might not know the names for that, so you need a good setup and know to read code documentation fast. But right now, Rust is better than ever because you can literally just ask KF for it, like I just did. Like logic was all there. This is exact same logic as I stated before, right? Exact same logic. It's not doing anything.
I like that
Interesting.
Claude added in review, telling you to review its code.
Oh yeah, no, because I asked it to. I have like a configuration here for Claude for how to do his job without fucking up. And like there are some things here which probably tell it to not. Yeah. Definitely have telling it not to remove my comments. There you go. So I have this line telling it to do this.
Okay. So if you want the middle,
so this is like very nice for this style of work.
then you add review. Okay.
Yeah, so they just tell it what to do, and then it like writes it out, and then
that's
maybe I can
above
check if
my
it's the same.
that is so far above my knowledge of how to use AI. Like
There's the tricks. You just
like
need to
I
like keep it contained because it really likes to cut receive reward. You just need to think about what is the reinforcement. We're talking ML at last. We went full circle. So you need to think about the rewards which it would receive during training, and how it's straight at the bottom. So actually, let's go to the drawing board. Where's the whiteboard?
we're back
We
to the
went full circle.
whiteboard. We're back to the whiteboard.
All right.
Okay.
All right. Let's see. I don't know. I think I can scroll it, but I will just like scroll below or whatever. So when we're doing ML, it sees a bunch of chars, right? Like say I have some phrase, and then it will. So firstly, we take all the chars and we make tokens out of them. How it's done currently, it will like go over the training inference dataset for tokens specifically, and will learn to tokenize sentences in the most efficient way. So we compress this stuff as much as possible. So for this particular sentence, if this is all we know about text, then we will go over it. We will note that there are two tokens of H in here. This is in this code. This is the first token which we started counting. It is twice. So first token, 0, now corresponds with H, single H. Now, we also see there are two A's. Now, we take the next one. One corresponds now with A. All right. Now, this, after every iteration, I forgot to add this. After every iteration, how to do... Wait. Do... Eraser... No? Is there no eraser? What the fuck? That's crazy. Okay. Let's just do this, I guess. So we now... Seriously? How do you do without... What?
Control Z. Control Z.
No, but Control Z... No, but I need to keep the rest, but... give me shapes, maybe. Shapes... But all right. We are organizing this part of the yak, and this part of the yak, and this part of the yak. Now, what the model sees here, the tokenizer, what sees there. Remember, we try to minimize the size, right? So what the tokenizer sees there now on the pass is it will see this is HA, so it will have 0, 1. This is A. V is 0. Or like token number doesn't matter, but it will know like it's token 0, token 1, token 0, token whatever. So it's like not it's more like T0, right? I'm just writing 0 or 1 the shortcut in right is 0 of token, first token. So yak is and inside the representation, it's also going to be represented by like a single 0 byte, or for the next one, it's going to be like 0 1, right? And then yak, like that doesn't matter. Yak is going to be a. So this is now 1, right? And so the next pass, now we are increasing all the sets of all the different things here. Let's see, we don't have anything interesting. Let's imagine the rest got somehow changed. And then we have, get me shape. Okay, say we did some overwriting, and now we have a bunch of tokens here. Some 1, 0, 1, 0, whatever. It will now look at the combinations of tokens. Well, not inside this one. I might need to think of better example. One second. Something where combinations of tokens actually become more prominent. For example, okay, the base, why not? So you have th here, you have th here. At some point, once we are done with t and say there is like base t something one here, right? So it will be kernelist. This will get tokenized. Then h get tokenized, and then something else will get tokenized, whatever. But we can also tokenize over tokens. So this will get like token 1, this will get 2, and then some token later, like token n, will have meaning of containing 2 of the smaller tokens.
Okay. So okay.
So this is how tokenization works. And then it will go and like reduce it down. Normally for like largest models today, it's going to be like 60k tokens, but you can make it do even just using charts as this. It's not the portion, but right now. So for example, like that's one of the. So like immediately the consequences of tokens, even before talking about rewards. Oftentimes, like for LLM, especially simpler one. These two are different. If you have hello dot, or if you have hello grab, this hello not equals to this hello, because during tokenization we learned that O and space is a very common token actually, and if we got to tokenization of hello, we definitely go to tokenization of hello joined with the space. So as soon as we started to recognize hello as a world, everywhere it saw a hello, it now saw also space after it, like in most cases. So it tokenizes hello with a space before it tokenizes hello with a dot.
Okay.
And this is huge. There are like today less than before, because they started being smarter with tokenizers and like accounting for this when generating producing tokens. But there's still like this is everywhere. And like for example, letters T. It will know the answer because it now has it in learning data, but before it wasn't said. Like it will know that it's free. But if you ask the same question like a year ago, it would not be able to tell you, because it doesn't see strawberry. It sees a single token encoding strawberry, as this is like a reasonably common word. Or it might see like 3 different tokens. It causing at least like, even if it doesn't see the token for entire strawberry, it will see a token for like straw, right? And it will see like probably token for berry, most definitely. See, it will have token for berry and like 1 or 2 tokens for the previous part. Right now it will think it will like reference existence from outside, and it will be able to say, but this is how it worked before. And also, if you ask it to now, I'm showing the screen, right? If you ask it to for ideas for how to name stuff. For example, I want to have a method to extend or reduce. Oh fuck! That already matches. Okay, that's bad. That's a bad example. Let's think of say warning levels. Okay. I want my words for warning levels to align. I'm seeing warn and for debug error trace. Find the words for this is like warn and info probably. No, trace and yeah. Find me words for warrant. Info to match their info. And it will be able to reason about this because I capitalized the letters. So you see, it offers correct responses. If I didn't capitalize the letters, it would have gone like it might pull out some code because now it knows to use tools. But here, like it's able to reason about this because there's not enough space in 1,000 tokens to see a capitalized version of each of these words. So it will be able, so it will see it. It will be forced to see it as individual letters.
Okay.
Yeah, that's another thing. What else? It's a prediction machine. So it's basically a fancy autocomplete. Like whatever we make of it, right? Like I have yuck. I wanna and it will like try to figure out what I'm trying to say, right? If I'm trying to shave it, if I'm trying to sell it, or whatever. If you throw in something to new context, it will change how it's reacting. So, for example, if you are angry at it inside a session, and you like it does something wrong, and then you tell it you are and can I type here now? Oh, whatever. An absolute buffoon. Right. It sees this in the context, and it will generate the next token, given the knowledge that the conversation partner for which it is generating tokens has been called a buffoon. So that will change the quality of the response because it will like it's not exactly what's happening, but you can think of it as it's pulling from different set of conversations that in which the counterparty is less knowledgeable.
So is this how AI essentially hallucinates? Does it just keep drilling down until it...
Yeah, exactly. Because it needs to continue. Like it will just tell you whatever sounds as a good completion for a sentence.
Wow. AI is the best
Yeah,
yes
because it's
man.
rewarded for it. Yeah. Yes, exactly. That's another thing. And so that's also why you really need to restart sessions if we did something wrong. So if you do not like results of some implementation, you maybe once can like show it the correct way and like, point out errors. But if it does it like twice within the same session, the session is to either roll it back or start a new one. If you try to continue in the same session, it will just get worse and worse and worse because it's trying to predict bad code now. So it's really funny.
That makes so much more sense, and I was wondering for like a while why exactly that does that, and that makes so much more sense.
Glad a bit of help. So this all comes like from very very basic learning. We can get back to it maybe for like the we have current budget problem, right? So you have a bunch of levers, which hopefully I think it works. Let's test if this thing works. I'm gonna review it. I'm just gonna run it. Why not? Weird current budget start and then defaults. So now it's listening on this port. Now I can say weird current budget pull lever 2. Now it do I need to what? Because I made it not positional. I made it as an arc. Normally you want to make positional, whatever. So I pull the lever. Now payoff is completely fucking wrong. Okay. Correct. Except it must be int with for within 0 to 1 exactly exactly, and payoff is always 1. Clear randomly, and this is proof is always 1 if it succeeds. It might have done like a more difficult version problem, so it's in trainings. There's like a way to extend on it. Yeah, because it introduces noise, and it does it over like a medium level value. Honestly, this is still like reasonable. It does work. It's fine, and it's actually like technically better, but it's slightly more difficult to reason about in this example. But the point is, yeah, we can pull a lever now. We got this. I don't know if it's much or not. We can try to do it again. One rotation. Currently changing stuff. And yeah, we can keep track of total amount of wins and when we do you have probably no. Does it keep track of it? Payoff. Hopefully it does. Whatever. Do you understand the idea of the game itself? Or do I need to explain better?
I'm getting the gist of it. Honestly,
yeah, so what's your like,
honestly,
strategy?
Honestly, it's making more sense to me than most of this did prior to this video or this stream. You kind of answered a couple of questions that I've had internally for a while.
Couple of questions. Yeah, no, for the game in particular, the Cairn budget with levers. Did it explain the game itself?
I'm still a little confused with the levers, and it's probability that we're doing.
Yeah,
here,
but
so
it's just levers. Okay, it's just like levers, and each lever has once this piece of shit fucking work. All right. Because we need to restart it, of course. Lever. Right. Win loss. Okay. Win.
Win loss.
Okay. Again, this is like a trivial change. You can't really fuck it up. Or if it does fuck it up, it's a self-contained. Okay. So like if it can drive it to the fucking ground. Because it like does incremental changes and goes around existing methods if it's simpler. Again, because it gets like reward for solving the problem itself, not for thinking. So it will solve the current problem, whatever the fuck it costs. If it needs to delete all your unit tests so that all the tests pass to match the requirements, it will do it. So
damn.
Yeah. It will find whatever way is necessary to get it done now.
Damn.
There are like some guardrails which have been introduced on top of it. The fundamental enforcement, fundamental desire, if you will, of the model is the same. Kind of working against it here, yeah. Alright, so within Swan, there we go. So right now, right, let me clear it. I've pressed I've pressed the lever 2 3 times. So far, this is fourth time. I pressed lever 2, and it gave me only one win. I have 96 tries left. I want to maximize number of wins. Say I get paid off some amount of money. So maybe I should go to a different lever. Let's pull lever, I don't know, 4. Oh, hell yeah, win. Let's try again. Oh, more win. Oh, hell yeah, let's keep pulling lever 4. Okay, I think wait, okay. In this particular case, you just keep pulling. Okay, so if you had like 2 losses here, there is a word, like, this is too many wins to stop at this point. Given what we know about the distribution, this is like almost enough to just continue pulling. But in most cases, you have like dynamic data, and then you always have a trade-off of whether you want to try to go find a better lever, or you want to stay on this one and just maximize the value until the end of your tries. So how would you approximately do the exploration?
Oh, I'd be random as fuck, just pulling random levers right now. If something worked, I'd pull it a few more times.
in the beginning, okay. In the beginning, let's average payout all right. And it will just do it. Oh my god, okay. All right, so try first, right? You have very little knowledge. So your lack of knowledge is called alpha. We can set it to something higher, say like 5, or actually, why not? We can set it or 0.8, something high. This means you have very little knowledge. So you are very incentivized to just explore, because you don't know how you can exploit at the moment. And the first try, you don't know, you always explore, right? So you take the first lever. For example, it's a win, so you have 1. The average value of this lever is 1, from which you observed. Okay, cool, let's try it again. You try it again, it doesn't work, you get 0.5. Right. Okay. We know that all the levers are somewhere between 1 and 0. So, like, what's our expectation for the best lever to?
I'd probably go to the next lever, because that one's a kind of a
No. But like in general, what's in here from all these 10 levers? What do we think is the best one? Like, what value would the best one have?
Wouldn't it be 1 if the? Or am I misunderstanding?
Well, we don't know that. No. It's like randomly distributed. So okay. I just randomly generate numbers from like 0 to 1. You think? Wait, it's back. It's not back. What? Okay. Weird. So we randomly generated. We know that it randomly was generated. And so, given that, what do you think the value is on the best lever?
Best lever. I'm not even sure. 0.9? No.
Approximately, yeah, more or less. Yeah, so if here we observed, again, we don't know this, but we tried it 2 times, and so far the average value of it is 0.5. So we most definitely, in the next 98 tries, can find a lever better than what this is looking as so far. And later on, we can come back to it and try it again, right? So we can test this one, for example. This wins, try again, loses. This is also like 0.5. This becomes 0. This becomes like 0.6. We tried it a bunch of times. it becomes like 0.7, and we tried it like a lot of times. Okay, now we're like iteration, I don't know, 30, with not even 40, we know values for all of them. And we keep 0.2, 0.3, 0.1, and so far we keep picking at 0.7, but now we have done 0.7 like 20 times, right? And we are very certain that this is exactly 0.7. So what we will do now is we still think like there's a room to grow. So maybe we miss something, right? So let's not pull it every single time. Let's pull it like 95% of the time. And so beyond that, let's pull a lever which is either closest to it, right? So in this case, it's 0.6. Either one with least number of tries, or in the best option, the combination of the both. There's a way to do it mathematically, to express this mathematically, but in layman's terms, we want the property of it having closest value to the current best, and being least explored, or like less explored than the others. So it has a higher chance of ending up behind above it, right? So if we know that this is like, if we even see that this is 0.1, it means that likely we have tried it a bunch of times and it didn't work out. I don't know why we tried it times to 0.1, but like we would never try this again.
Right.
There's like no way that it would beat 0.7. But 0.6 maybe, sure. We only tried 0.5 two times. So let's keep trying it. Try it once again. It wins. It's like 7.5, right? Okay, cool. Now, this is not the best lever. We don't know this is the best lever. But, well, okay. That depends. This is like more math on how expectations go against certainty here. So in like different situations, within like 2 or 3 last rolls, there are different decisions that get made here. But in this particular case, with many rolls left, the best lever. So we try it again. We get like have like 8 to whatever, and now this is the best lever. Okay, cool. Because we were willing to explore, we found the best lever after all this time, and we did not get stuck on 0.7. But at the same time, we didn't keep hammering like a worse lever in hopes that it would improve. So what we're doing here is again balancing exploitation with exploration, and this is expressed in alpha, which I mentioned before, probably earlier than it needs to be mentioned. In here, when I said like we want to do this 90 or 95% of the this is expressed as 1 minus alpha. So, and this is like 0.5, thus alpha currently at this point is 0.05, right? And as the t goes to the right, we want to reduce alpha. Does it make sense why?
Because we know it's on the... We're getting a little further away from it, right? Like we know we're getting further away from what we want.
No. It means again here alpha, right, is subtracted from probability of 1 for our willingness to exploit. So the smaller the alpha, the more we will exploit. And we do this because we, at this point, more time has passed, right? So we have higher certainty that our data of all the levers is closer to reality.
Okay.
So there is like some bit more complex equation, but you can think of it as like alpha going down as time goes to the right. That's the current benefit, and this is underlying all of reinforcement learning. When you, for example, think, I think it's like the thing I mentioned, and we'll not even get this time to actually write something, which I thought we would, but we're not here because it's easy, but because we thought it would be easy. So let's see. I cannot remove more than this. What? Okay, wait, we're stuck with this.
Love it.
Okay, what's this? Let me mention, connect this with the rest. All right, this is how our erase works now. Let's see. Okay. Now, when you have, say, a best chess move, say. Uh,
Oh, that's a little easier on the eyes.
oh yeah, but let me think of a good situation. Oh yeah, for example, so when you have all right, when you have a chessboard, can I? Okay, throwing is hard. Throwing is hard. Let's see, like this, like that. This is now a chessboard. Haha. Yeah, just yeah, believe in it. Until believe in you. One, two.
This is
Oh
that
goodness.
multi-dimensional chessboard.
Yeah, exactly. Okay. Oh, fuck. I read it's really hard. So okay. Say we have like a key here. Okay, we will not. Let's try to get an actual board. Just new party. Yeah, new party. No, fuck. It's not. Ah. Okay, I have like some toy game which I did some rel before with. Let's do that. It's much dumber. It's much dumber, and I cannot draw chess apparently. Um, it's like really stupid game. Really stupid. Come on. Well, we're waiting for Nix to load. This is no trust. It's no trust. It's Nix's fault. Let me try to draw more chess while it's loading. So we have a rook. No, we don't have a rook here. So say we have a rook here, right? This is fuck it, rook. This is a queen here, an enemy queen, black queen, up. And then this is a queen, like a king somewhere, some other pieces. Okay, so if the white captures the queen here, we have a rook, enemy rook here, which will do checkmate. That's the problem. So if we do natural, and say we do like the stupid way of counting value of positions, we might end up with the defining it over value of pieces. If it is defined over piece value, then the next move of taking the queen is an enormous win, right? So it's going to be like +9 or like +10 point something like 1, 2 by the new system, whatever. But the very next move you will get checkmated because the rook moved away, right? This is not easy to understand because this is 4-dimensional chess. But this is it. If you do MSTR, you can generate values forward. You can sample those values. So you can draw kind of a tree from the current position, and you can see at the things you can take, at the options, at the paths down. So here is take a rook, right? You get a queen, you get like +9, +10. Here is like other position, like you get +1 here, you get 0 here, 0 here, for example, right? There's like 4 moves you can do in this position. In reality, much more, but whatever. Maybe like -5 if you can get rook on the next move. And then we can also go, and then for each of those, check what happens if we do random play from them, or if we do evaluation on them. So we can evaluate the current position with future like samples in mind. For example, from here we can then do random play and see that most of like it's slightly more often ends up as good, okay? Because this is random simplest version of MSTR. Then from here we will look at the moves for black, and then by the random play, we will recognize that, oh no, because we explored this more, right? Because it's got good value. So because we're exploring this more, we will see that we will sample more moves for black, And for black, we will find by the random play the move of putting rook here, and oh my god, this leads to checkmate. And because this leads to checkmate, we will be able to then it's not really back propagate. This is like half back propagate. This is an overloaded term. But we update the previous value to now knowing that, oh, this is not 10. This is much worse than 10. The actual value of visiting this position, given optimal play from a point which we assume, so we assume that it will take for a mate if it exists, then this is not 10, this is minus mate. Does it somehow make sense, or should I open a simpler game?
No, it's making some sense to me now. So like, because we're going down this path, but because this path leads to ultimately a bad
Yeah,
outcome,
and
it's got a lower value.
But the most interesting thing is that we continuously explore it. So even like before that, before the position, we reason about every node as also like an lever, right? And we try to figure out how good it is to pull them. And if we think that the lever is good, we will explore it more and we will go down from it. And to evaluate every state, we do like some algorithm. So it can be evaluation of the current like algorithm, whatever it is. It can try to evaluate the node down there, down the tree, or we can just like random play and see it will go to the end and see if it's like a winner or not, right? And this also will find. Well, it can take any algorithm and just like improve because it is a way to discover, not to discover, but explore the best, most interesting places and then learn around them.
So this is similar to like breath first searching, is it? Or like a tree, or
Well,
like
kinda, yeah, no, you literally have a tree. You do have a tree. This is incentivized searching. So the same thing, like we have kind of our understanding of how good is the current node, each node, and we have a budget of explorations because like this rollout is cheap. Every time, like we need to finish the entire game, oftentimes, to evaluate the value of the node, right? So if it's not maybe chess, maybe it's like checkers. Checkers is more difficult if you have a good position. You have like random moves until the end of it, and then you see if it's like a win or loss, and then you write that value back to our knowledge about the expectation. So the same as you, right? You got 0, loss, or you got 1, you won. Same thing. We just get back to the lever, and we update our knowledge of the lever with knowledge of like the last rollout. And we not only update the lever at the from which we ran, we update all the ones above it because they lead to this new one.
Okay,
So we update the
sense.
entire path.
That makes sense.
And well, the actual training I think we will leave for later. This is the harness, how you like attach something, say game, a station for exploration. I think that's as much as we have time for today.
Yeah, I think we're gonna have to maybe go into, maybe if you're available tomorrow, we can kind of dive into a little bit of code, or
I don't know about tomorrow, maybe like next week, probably. But I will still have like all the same code.
okay.
Maybe it might be like a tiny bit more prepared. I don't think so, but we can hope. Anyway, like yeah, I have this repo. I might have more stuff by then.
Okay. Yeah, no, we can.
And yeah, there's like a natural continuation to what I'm talking about.
Okay. Well, yeah, we can we'll prepare another week to do some actual code now that we got the explanation out of the way.
Hey, we did a lot of Rust code already.
Yeah, we did a lot of testing too.
So yeah, good stuff.